Music for a child's heart, body, and mind.
Morning, Sardonyx. You're welcome to another mathematics class. How was your weekend? Alright, today we'll be considering another topic. It's a new topic. It's a topic we're familiar with. We've learned it in our basic science over time. We're going to be looking at the mathematical part of it today. The topic is temperature. So join me as I take you through the topic for today, temperature. Action. Now, temperature is our topic. Of course, the subject is mathematics. Temperature simply means the degree of hotness or coldness of an object or a body. It's a very common definition. We've learned that over time in our basic science. It is the degree of how hot or cold a body or an object can be. And the instrument used for measuring temperature is thermometer. That I want to believe we can still remember as well, okay? Okay, there are two main scales for measuring temperature. I repeat, there are two major scales for measuring temperature. Scale is called the degree Celsius scale. I repeat, the degree Celsius scale. And you can see the symbol in bracket here, degree of course, and capital C represents Celsius. So that's the first main scale for measuring temperature. And the second main scale is the degree Fahrenheit scale. I take it again, the degree Fahrenheit scale. And the symbol is what? Degree and capital F. That represents degree Fahrenheit in temperature, okay? Now if you look at the lower part of the board, we have two scales that we have drawn there. The degree Celsius scale and the degree Fahrenheit scale. So we are going to compare them and look at the differences between these two scales so you can have a better understanding of what we are looking at today. Now on the left hand side here, the first one is the degree Celsius scales. Now for each of the scales we have here, there are two fixed points, the upper point and the lower point. For every scale, now the upper point here is called the boiling point, BP. This BP here stands for the boiling point, that's the upper point. And the lower point is called the freezing point, FP. FP stands for what? Freezing point. Now let me explain the meaning of these two. The boiling point is the temperature at which water starts to boil. The temperature water gets to and it starts boiling. While the freezing point is the temperature water gets to and it starts freezing. Okay, so degree Celsius has its boiling point and its freezing point. Going to the right hand side, degree Fahrenheit scale, there is a boiling point and there is a freezing point as well. Okay, coming back to degree Celsius, the boiling point on degree Celsius scale is 100 degrees Celsius. This implies that this is the temperature water gets to and starts boiling. The freezing point on degree Celsius scale is 0 degrees Celsius. What does this imply? It means when water gets to 0 degrees Celsius, it starts freezing. On the other hand, for degree Fahrenheit, the boiling point is what? 212 degrees Fahrenheit. This is the temperature water gets to on this particular scale and it starts boiling. While the freezing point is what? 32 degrees Fahrenheit. Okay, the last thing I would like us to compare about these two scales is their division. Their division, okay? For the degree Celsius scale, how do we find division? Division is simply the difference between the boiling point and the freezing point. So for us to know the division on this scale, we do what? 100, which is the boiling point, minus 0, which is the freezing point, and that gives you 100. So it means we have 100 division on the degree Celsius scale. While coming to the degree Fahrenheit, division will be what? Still the difference between the boiling point, which is 212, minus the freezing point, which is 32. And that gives you what? 180. So note that the division on degree Celsius scale is 100, while the division on the degree Fahrenheit scale is 180. Okay, one important point I want you to note is this. The most commonly used scale is the degree Celsius scale. And what exactly does this mean? You can see that 0 is the freezing point here. And anything from 0 below, you start going to negative numbers. So the moment you start going below 0 to negative numbers, the cooler the object becomes. Because at 0 degrees Celsius, the object starts freezing. So the moment you start going below it, going to negative numbers, -1, -2 degrees Celsius, the cooler the object becomes. And the moment you start going above it, increasing from 0 to 1, 2, 3, up to 100, the hotter the object becomes. Okay. Okay, now let's look at the ratio between the division of the two scales. So for example, the ratio between the division of degree Celsius to that of degree Fahrenheit gives you 100, ratio 180. And we have learned about ratio. You know, this simply means 100 over 180. As a fraction, you must take it to the lowest term. So 0 will cancel 0, 2 in 10, 5, 2 in 18, 9. So you can see this now. What exactly does this imply? It means the ratio of the division of degree Celsius to degree Fahrenheit is what? Is 5:9. On the other hand, what will be the ratio of degree Fahrenheit to degree Celsius? That will be the opposite. That will be what? 9:5. Now from this ratio, what can we deduce? It simply means 1 degree Celsius will give you 9/5 of degree Fahrenheit. And conversely, that is the opposite side, 1 degree Fahrenheit will give you what? That is opposite 5/9 of degree Celsius. So just understand and follow this derivation. In case you don't get it once, you can play it back to get it again. Now from this, now we are going to derive a formula, and that formula helps us to solve what we are looking at today. Okay, now we are going to this part of the lesson, conversion from degree Celsius to degree Fahrenheit. How to convert temperature that is in degrees Celsius to degree Fahrenheit. And the formula for doing that is this. Temperature in degree Fahrenheit will now become temperature in degrees Celsius times 9/5. This dot means times. Then everything plus 32. I repeat, for you to convert from degree Celsius to degree Fahrenheit, the formula becomes degree Fahrenheit gives you degree Celsius, the temperature in degrees Celsius, times 9/5. I want to believe you understand how we came about this 9/5 earlier when I derived it. But why are we adding 32? Because you are going to degree Fahrenheit. And remember, the freezing point for degree Celsius is 0, while that of degree Fahrenheit is 32. So that 32 difference is what you are adding to it here. Because you are going to Fahrenheit, so you must put the 32 that is in Fahrenheit to whatever you are doing. That is why we have the formula this way. So from here now, we'll take a few examples and then we apply this formula to solve them. So examples: convert the following temperatures to degree Fahrenheit. So number 1, let's have 20 degree Celsius. Now this 20 degrees Celsius is in Celsius already. We want to take it to Fahrenheit. Applying our formula here, so what do you simply do? You have what? Temperature in degree Fahrenheit now becomes what? Temperature in degrees Celsius, which is 20, that's 20. The dot here means multiplication. The dot at the top here means multiplication, the dot here. So what do you say? 20 times 9/5, all in bracket. Then you add your 32 to it. So you remember how we solve multiplying a fraction? You divide out 5 here, 1, 5 here, 4. 4 times 9. So temperature in degree Fahrenheit gives you what? 4 times 9 gives you 36, plus the 32 outside. So the answer becomes what? 68 degree Fahrenheit. So in other words, 20 degrees Celsius in Fahrenheit scales becomes what? 68 degree Fahrenheit. Example 2. Convert 18 degrees Celsius to Fahrenheit. Our formula again. What does our formula say? That is degree Fahrenheit gives you the temperature in degrees Celsius times 9/5, all in bracket, plus your 32. So it becomes what? What's our degree Celsius? That's 18. 18 times 9/5, all in bracket, plus 32. Okay, there's nothing to cancel that here, so we have to multiply the numerators. So temperature in degree Fahrenheit gives you what? 18 times 9 gives you 162, all over 5, still in bracket, plus 32. So we have to divide out here. So 5 here 1. 5 in 16 is what? 3. Remember 1. Put the 1 there to make this 12. 5 in 12 gives you what? 2. Remember what? 2. Of course, 5 cannot go in 2, so you add 0 to it. And you put your point here. Remember the way we divide to get decimal. So 5 in 20 now gives you what? 4. So what's the answer? 32. You know 5 in 20 is 4, remainder 0, so we don't have to continue. That's 32.4 plus what? 32. And how do we add our decimal? I will do this for the sake of people that have forgotten. That's 32.4. You know 32 as a decimal is same thing as 32.0. So what do you do? 32.0. So add together, that gives you 4.46. So what's the answer? 64.4 degree Fahrenheit. So 18 degrees Celsius in Fahrenheit gives you 64.4 degree Fahrenheit. Number 3, and this will be our last example for today. Number 3, 45 degree Celsius. We have to express this as degree Fahrenheit. So still using our formula, temperature in degree Fahrenheit now gives you temperature in degrees Celsius times 9 over 5, all in bracket, plus 32. So let's substitute. Temperature in degrees Celsius is now 45 times 9 over 5, all in bracket, plus 32. So something can cancel out. 5 here, 1. 5 in 45 is 9. So 9 times 9 becomes what? 81 plus 32. What will be your final answer? Your final answer should be 113 degree Fahrenheit. So in other words, 45 degrees Celsius in degree Fahrenheit scale is 113 degree Fahrenheit. Alright, Sardonyx, this will be the end of this morning's class. It's a new topic. I would like you to watch the video over and over again to understand the content. Note the formula, look at the derivation. It will help you a lot while taking the class. Like I always advise you, copy your note and watch the video for explanation. For the examples, you will find the questions in your note, but the solutions will be found in the video. And for the scale as well, I will leave a space in your note. So you are expected to draw the scales, the two scales from the video in that space that will be left in your note. Classwork and homework will be waiting for you in the portal. In our next class, we hope to take the opposite, which will be conversion from degree Fahrenheit to degree Celsius. Till then, take care of yourself and be fine. Bye.